in example 3, we're going to take inverses of both exponential and logarithmic functions. When you start with an exponential and you want the inverse of that, first thing, if it's in function form, we're going to write it as an equation. So we're going to replace f of x with y. Then we're going to switch x and y, right? That's the same process we learned last chapter when we were doing inverses of radical functions. Same process, right? Switch the x and the y. Now we've got x equals 10 raised to the power of y plus 1. Then the whole goal is to solve for y. So we're going to go from exponential form to log form, right? This is now log base 10 of x is equal to y plus 1. I'm solving for y, I would just then subtract by 1. So then y is equal to log of x minus 1. And if you look at them on the graph, they are inverses. Part B is not the opposite, but we're going to take the inverse of a log function now. Same thing. Change it out of function notation. So now instead of g of x, you've got a y. Then you interchange the x and the y. And then now we're going to solve for y. If you have a log equation, we're going to rewrite it as an exponential equation. And now you got y plus 5 is equal to 7 to the power of x. Subtract 5, and you get y equals 7 to the power of x minus 5. And then again, if you look at both those on the graph, you can see that they are inverses. You got 2 to try, 1 of each kind. So pause it, give those a try, and then come back and we will compare answers. All right, in blue, I looked at part A. So first, changed it from f of x to y, then switched the x and the y, converted it to a log equation, subtracted 2, and you end up with y equals log base 3 of x minus 2. Part B in red, again, flipped out g of x for y, switched the x and the y. Here you add it 2 to both sides. Before I convert to an exponential form, I don't want that minus 2 there, so I add it 2 to both sides. Then the x plus 2 becomes the exponent on the base of 7. That's equal to y. All right, let's take a look at example 4.